Hello everyone, welcome to step 421. I hope you guys all are healthy and safe. Since we had a week break and also this is a new way of the lecture delivery, I think it might be a good idea to spend 10 to 20 minutes on reviewing the materials that we covered in the last class. So let's go on section 1, the sample size allocation. So the basic setup is a stratified random sampling. Step 1 is the stratification. Step 2 is the sample size allocation, which will be the main topic of this class. Once the sample sizes are determined, then we'll apply simple random sampling with each stratum independently in step 3 and then estimate. Now, the second step is the sample size allocation. The main idea is to investigate the variance of the sample estimator of the total and see how the variance term is expressed. So in terms of the sample sizes NH, this is the expression. Okay, so actually I can show you one more. So if you write it one more term, something like this, this is actually NH square SH square over NH minus NH SH square. So second term doesn't depend on NH, and the only one, the NH is here, right? The NH is here. So we are the sample size allocation is investigating how to take care of this first term. So now the sample size allocation problem is this: given the sample size, how to allocate NH such that this relationship holds. So N, so given N, right? How to determine NH? There is no NH here. Okay. Oops. Okay. One popular approach is the proportional allocation. The idea is to allocate the sample sizes such that the within stratum sampling rates are all equal. There are two main properties of the proportional allocation. One is the sampling weights are, the first one is that the sampling weights are all equal. The other is, which is very important, is that the variance on the proportional allocation is smaller than the variance on the simple random sampling with a sample size. So this is important. We'll study two properties of the proportional allocation in more detail. In stratified sampling, the unbiased estimator of the total can be written as a weighted sum of the sample observations, and the weights for the sample element I in stratum H is WHI, which is so this is the weight, and the weight is capital NH divided by small nh. Since the sampling rates are all equal in the proportional allocation, and the sampling weight is the inverse of the sampling rate in the stratified sampling, so that means the sampling weights are all equal on the proportional allocation. So if the sampling weights are all equal, it is sometimes called the self-weighting sample. The examples of the self-weighting sample designs are simple random sampling, systematic sampling, and stratified random sampling with a proportional allocation. Okay. I will skip this example as I covered in the class last week. Now, we'll discuss the second property of the proportional allocation. To discuss it, we need to investigate the form of the variance on the proportional allocation. The main result is the last one, this expression. Oops. Okay. The main result is, sorry. So this is what we want to show. Okay. So here's the proof. Okay, let's do it. So the first equality is the definition, the formula for stratified random sampling. Second equality holds because of the definition of SH. Third equality holds because it's just algebra. The first one is an approximate equality, not exact equality, where on the proportional location this guy is equal to this. So this one is true on the proportional location. And then the second thing is that if the NH is large, this one is NH is large, then the ratio is approximately equal to 1, and so that provides the result, the final result. Okay. So we'll so the main message is that on the proportional allocation, the variance on the stratified random sampling is no bigger than the variance on the simple random sampling. This is this result. Okay. I will skip the proof as I covered it already in the class before. So I'll just skip all this. Here's this is something in the remark. Basically, okay. So in the remark, the variance form is this form, which is this form, which is contains S W square. So if we use S square, then the variance form is actually simple random sampling, right? But now we change it to SW square, where SW square is the weighted average of the stratum, weighted average of the stratum variances, where WH is the it's a typo. It's not. It's the stratum weight. So that basically what the proportion that stratum H represented a finite population. Okay. So that's the first part.